we want to consider the oxidation of NO to NO2. So they've given us the equation. And if you watch another video of mine, you notice you got this 1/2. Remember, if it's provided to you, that's correct. So don't try to change that, because if you do, then you're going to change the outcome. And they want us to calculate the value of delta G Rn at -55. This is just like another video, but the temperature has changed. In case you haven't watched that video, I want to walk us through exactly how to do that. All this information right here in kind of this pink color is actually from your textbook or from a chart, your ebook, whatever. I've put it here for practical purposes, so as I add things down, you know exactly what's going on. If you recall, delta G equals delta H minus T delta S. Well, in this case, we're looking at a reaction, so now we're just going to have these in conjunction as with reaction values. So that means we have to actually find delta H and delta S. And if you remember how to do that, you take the sum of the products minus the sum of the reactants. So I want you to try that, and then I want you to come back and check your answer. So I went ahead and did delta H of the reaction. And remember, it's the number of moles times the value from the table. And the only one I have on the products is the NO2 minus the sum of the two on the reactants. And I got that in kilojoules. Now remember, I put that in joules so that I would be able to combine like terms later. I did the exact same thing for S. So the hardest thing here is remembering what to group together and to multiply by how many moles. So remember, how many moles is the coefficient in front of that molecule in the equation. Now I do need to convert temperature into Kelvin. So I've added 273.15 plus minus 55 to get 218.15 Kelvin. Here is my equation now with all of the reaction part added in, and now I'm just copying down what I did up here in the previous 3 steps. And then when I do the multiplication and the subtraction, I get minus 42109.605. Now this is in joules. Remember, we need it to be in kilojoules, so I'm going to divide by 1000, and that's going to give me negative. Now I went ahead and rounded because I know up here that's my given, but each of these has 3 significant figures and these have 4. So I have 3 significant figures in my answer, and this is in kilojoules. So this is what delta G is. Now, since it's negative, we know it's what? We know that it's spontaneous, and then if the number for the temperature gets more negative, that's a lower temperature, correct? Is it going to become more spontaneous or less spontaneous? Well, it's going to become more, right? And if you're not sure about that, what I recommend is that you redo this part right here and use a number smaller than -55. And you can always do that. I mean, it's not going to take a lot of time because you've already done the calculation once. And then if you plug that in, you're going to know for sure if you can't just see that just from, me saying it or someone else telling you that.